Okay, so in this lesson, we're going to be talking about comparing and transforming linear functions. So we've worked with how to write linear functions, how to graph them, and the other big skill that you all need to know is about how to transform them. And this idea of transformations is really going to apply to all year long of Algebra 1. You're going to look at it again in geometry and all over Algebra 2. So we want to make sure we get a good foundation here. So the first thing is just talking about what a function family is. And a function family is a group of functions or graphs that look similar and have similar characteristics. So this is just a picture of what I have on the wall. And these are all different function families. So we have mostly just talked about linear, and all linear functions are straight lines, you know that. But there are these other function families. For instance, any absolute value function is going to be this same general V shape. Now it might be upside down, it might be wider or shorter, or start in a different place, but it's still going to be that same general shape. The same goes for, if I just pick another one, quadratics, all right? Quadratics are always going to be this same kind of U shape. They might be stretched out to be wider, or they might be skinnier, or start in a different location, but they're all going to be that same general shape. All right, so that's what it means to be a function family. So right now we're still focusing in this linear function family, but it's know that everything we're going to be doing or talking about applies to these others as well. So parent functions, all those families have parent functions. They're just the simplest version of a function in that family. So when we think about a line, we want to think, what's the simplest line equation that we could come up with? And remember, lines are kind of, if we talk about graphing, there's two big important things that we usually use, and those are the y-intercept and the slope. So we want to think about what's the simplest slope that we could use, and that's generally going to be 1, right? Rise 1, run 1, so that's y equals 1x. And then the simplest place that we could start would be at the origin, so that would be plus 0. Now there is an easier way to write that, and so the way that you're going to see it most often is either y equals x or f of x equals x, because both of those still imply that you have a slope of 1 and a y-intercept of 0. So that is the parent function that we're going to use to compare all other linear functions to. And so the parameters of linear functions, we just talked about that. The two things that we use to kind of compare or measure linear functions are going to be the slope and the y-intercept. Okay, so let's talk about 3 types of transformations. What I have here on the left side for you is just showing you some transformations on quadratic functions. You do not necessarily need to draw these in your notes right now, but I do want to just show them to you for the sake of an example. So one of the things that we can do with this quadratic shape, so this is a U, we can shift it down or even up or to the right or to the left. So notice that in this first example, nothing is happening to like the width or the height of that quadratic, assuming that I'm drawing well, but rather the quadratic itself is just moving in different directions. So that's one of the transformations that you want to list, is that things can shift. And in a linear graph, we said, really when we talk about a line, we can talk about lines shifting left and right, and that does happen some, but for the most part, since with lines we're talking about the y-intercept, we're really going to focus on shifting up or down since we're addressing the y-intercept here. So for example, you could have, like this parent function starts at 0, a shift up could be if I had a function that looked like that, right? It's shifting up, it has a higher y-intercept than it had before. All right, this second example in the quadratic section, you can see that this quadratic is getting skinnier than maybe it was before, or it could get wider than it was before. Well, lines don't really get skinnier or wider, so we don't use that vocabulary, but for a line, we can talk about how the steepness is going to change. And these are going to be changes to the slope. So if you think about, again, that parent function is just going to have a slope of 1 over 1. Right, so if we want to make something more steep, that means we need to change the slope to be something greater than 1 over 1, right? Like 3 over 1. That's going to give us a greater slope than just 1 over 1. If we wanted something less steep, then we could make the fraction, make it like a fraction, something that is less than 1 over 1. So we want to say that things that are more steep have slopes that are greater than 1, And things that are less steep are going to have slopes that are less than 1. And I'm actually going to add something to that. I also want it to be greater than 0, and you'll see why here in just a second. So if we look at this last quadratic, notice on this last quadratic, we've taken the parabola shape. You don't know that that's what that's called, but it is. We've taken this U shape and we flipped it upside down. And the math word to flip is to reflect. And so for a line to reflect, again, we're going to start with this parent function of 1 over 1. For a line to reflect, you think about if you flip a line, that's going to cause the line to go the other direction, or that's to say to go down. So a reflection is really going to be when we have a negative slope. So that's why I've said that about being greater than 0. Reflection is when we have a slope that is less than 0. Less than 0. Or you could say a slope that is negative if you want to word it that way. All right? So just to show you this in practice, I'm just showing you these two examples. You don't need to have these in your notes because we're going to practice some more together tomorrow. But I want you to see, if we talk about these 3 lines and compare them to one another, notice that all 3 of these, first of all 3 of these are lines, so they're in all the same family, the linear family. Notice that all of these lines appear to have the same steepness, right? If you were to walk up, if you think about these as hills, if you were to walk up any of those, the steepness would be the same for all 3 of them. What is different are these y-intercepts, right? This top line is starting at 2. This line here in the middle is starting at the origin or at 0. And the bottom line is going to be starting there at -1. So if I was to write equations for any of these lines, what I want you to note is that all 3 of these lines have the same slope. So they're all going to have this same mx part, right? The m is going to be the same on all of them. What's going to be different is this b quantity. This is going to be different because they're starting at different y-intercepts. If I erase here the original equations of the lines, you can see that that is true. They all have the same slope because they have the same steepness of 2, but they have different y-intercepts. So if we look at the second example, notice that all 3 of these have the same y-intercept. So in this case, mx plus b, it's the y-intercept that's going to be the same. They're all starting at the same y value, but the slope is going to be different. And what I want you to see here specifically, let me zoom in. What I want you to see is that how these lines compare to one another. So if I think about this dark line, I'm going to compare to this line right here. I'll make a star. If I think about this dark line right here, this line is very similar to the line that I wrote with the star, except for that it has a negative slope. So they're both the same steepness, right? I got up 1 over 1 on the line with the star, and I've got down 1 over 1, down 1 to the right one on this darker line. So they're both the same steepness, it's just that one is negative. And remember, that's what we call that reflection. And then if we compare this kind of lighter looking line here, I'll go ahead and make that one yellow. If we compare the lighter looking line there, that one is going to have, again, the same y-intercept. It has a different slope, and it's a steeper slope than the one that I drew with the star, right? The one that I drew with the star has a slope of 1 over 1, and this yellow line has a slope of 2 over 1. So that larger slope number is making it steeper when we look at the graph. All right, so let's look at one real-world example. This graph shows a gym that charges a monthly fee of $25 and a registration fee of $50. All right, so notice the monthly fee, that's the $25 monthly rate. And then the registration fee is going to be the y-intercept there, which is just plus 20. So they want us to do 2 things. The first thing that they want us to do is create a gym plan that has a higher registration fee. So that's the only thing that they're telling us to change is the registration fee. So an example for that could be f of x equals, I want the monthly rate to stay the same, but I want the registration fee to be higher. So instead of $50, maybe let's charge $75. So if we think about how that line is going to compare, the slope is going to be the same, but it's the y-intercept that's going to be different. So this is going to be an example of something that is going to shift up because the y-intercept is all that's changing, not the slope. And in fact, if I graph that line, I notice that that line does have the same slope, just a higher y-intercept, so we call that a shift up. All right, I'm going to use the same idea. This time I want to create a gym with a lower registration fee, but a higher monthly rate. Okay, so I'm going to start with a registration fee. I want a lower registration fee. So I'm going to say instead of $50, maybe we'll say $40. And I want a higher monthly fee. So instead of 25, I'm just picking numbers here. Let's say 30. All right, so that's 30T plus 40. That's f of t. Okay, so there's my function, and this time if we talk about how will the line compare. So this time, since my monthly rate is higher, that means my slope is going to be steeper, and this line should look steeper when I graph it. And this registration fee is lower, which means it's going to have a lower y-intercept, or that's an example of something that is going to shift down. So it's not perfect, but I went ahead and drew you just kind of a rough sketch just so that you could see this is in fact steeper than the original line, but it does have a lower y-intercept. So it's not that the entire line is underneath the original line, it's just that the y-intercept is at a lower point. So that's why we call that a shift down. All right, so have your notes ready for class tomorrow.